So, very good morning, everyone. Let me start my today's class. Last time we have already discussed heap sort, the basic idea. So quickly revising and refreshing those contents, and then we will continue here for the same coding and analysis part. So regarding heap sort, we have already discussed the basic philosophy. If you remember, we started talking with concept of a full binary tree. Then we talked full binary tree versus complete binary tree. From there, we discussed the concept of a max heap. And then we also discussed the math relations of mathematically for any node I, 2i being the left child, 2i plus 1 being the right child, and I by 2 being the parent. Those relations we talked. This is for the left child. This is for the right child. And then we talked of the parent also, provided the node exists, provided each of these values, say 2i is less than equal to n, then only the node exists. 2i plus 1 being less than equal to n, then only node exists. I by 2 being, say, greater than equal to 1, that indirectly means that is I being greater than 1. So if this is there, then these relationships exist for any node I. And then based on that, we discussed that ultimately our total logic requires one operation which we call as a max heapify. And other operation which we needed was a build max heap. And then using these build heap or build max heap, whatever you say, and then you will call these and use this in the heap sort for swapping, etc., and using this along with the value 1 being swapped, etc., all that, the logic. So we have already said that everything being done over an array, and there is no concept of a pointer or binary tree actually being implemented. So all implementation and all logics will require the array and array indexes to be used. No pointers, no binary tree actually made. So we are not going to create any binary tree in this situation. Assuming this, let's continue and make the corresponding logic to this. So if I talk of this, yeah, I'll resume here. So if I talk of this now, then I say, let's try to make the logic and programming for this. Last time also I said that initially I'm going to do some programming, but later you will be writing the code of your own based on the logics explained by me. So for the time being, I assume whatever syntax you are supposed to give, all that you will give, etc., etc. So here, the step 1, we have already said, will require a build max heap. So we have to decide what parameters do we need to pass. In this case, what parameters should be there, you have to think of. And obviously, in minimum, I require array as well as the total size. These two always needed. Additionally, if you need, you can think of anything. So if there are many more. Then once max heap is ready, effectively what I needed is swap of array 1 versus array n. And then n to be reduced to n minus 1. Now, first element has been probably disturbed and all others are satisfying. So effectively node 1 is not satisfying, but its children are satisfying. That is an ideal situation to call max heapify. And for max heapify, obviously the parameters. So we will require array, obviously, n also. And which node number, in this case, the node number 1 needs to be adjusted, node number to be heapified. So we call that as a heapification operation, and this is being passed. As we said that this needs to be repeated, so we have to repeat it. So effectively, how many times to repeat? I can say exactly n minus times the repetition should be sufficient, although we can write n times also. But if n minus times you have repeated, after that only one node will be left in the array, and one node means automatically sorted. So I can repeat it. You can have a loop. Now here you can have a for loop because exactly n minus 1 times variable doesn't matter. So you can accordingly write that code. Then comes one by one. Let's make a build max heap. So build, or I'll make the logic for build max heap. Then build max heap, if I say, if I want it to be void or whatever, I have to decide. And if I have a build max heap, there also effectively, I remember correctly that only non-leaf nodes need to be heapified, and that also in the order of a downwards, means backward direction from the last non-leaf onwards up to the root. And non-leaf nodes are effectively already known to me that they are going to be n by 2. This floor is needed if I have n as odd number. Otherwise, definitely I can have the corresponding even number will be straight away. And of course, I need I greater than equal to 1 because up to root I have to repeat. And then if I am doing like this, I want to call max heapify. So max heapify means what? Max heapify which particular node? So I node number I is to be heapified in this case. So that can be the max heapify, build max heap operation. Then coming to the last operation, max heapify, whatever parameters needed, etc., whatever return type needed, you can decide accordingly right here, plus you node the node number I. So now I have to effectively find out here that what is to be done. In this case, the assumption is the current node I might not satisfy the property, but its children are satisfying. So the root value might go downwards up to certain level. Obviously, that means I have to find max out of current node I. It's 2i and 2i plus 1. Provided these exist. Of course, if the value is out of range, then we will say compare with the remaining. So, of course, if my max is greater out of array I, if it is not the root itself high, then I have some situation. So if max is greater than array I, now there can be one situation. First, that the left child was greater. So that can be one situation. That will mean effectively swap the array ith value versus the left child. Else, there can be second case that right child is greater. If I have already checked that condition, obviously means either left is greater or right child is greater. That will mean the swap the corresponding value with the right child. Left child effectively means the corresponding 2i. Right child effectively means a 2i plus 1. So this is a swap to happen. And if a swap happens, after swap, the same process is to be continued towards the left child, because the left child has got the roots value which was a lesser and the left child was greater. So left child itself might have got the disturbance now. That means I have to max heapify again. So it can be a recursive function also. I can max heapify with whatever parameters and the 2i index. and that will be over. Else, if it is a right child case, that means I am going to have this swapping and then max heapify to be called again towards right child. That will mean the index will be 2i plus 1 plus whatever parameters. What if this was not max? What if this is not max means the current node itself is greater than its children? That means nothing else to be done. No need to go to the children side at all. The work is already over. So I can have this stopped. Now, obviously, whenever you are writing a recursive function, this both are recursive. So we must know when will it stop. Ultimately, recursion should never become infinite. So we must have a reason to stop. Obviously, when it will stop, either the swapping doesn't happen. So if swapping doesn't happen, this situation will come. No swapping will mean no recursion. No swapping automatically means no recursion. This will imply no recursion. Or other case could be that you had reached to the corresponding children not existing. So it might happen that you have no more children existing. The left child or right child or both doesn't exist. And if both don't exist, obviously the recursion will accordingly stop finally. So that check has to be there. If I say that left child, I have to always make sure that the child exists, if exists. So that will be always a condition. Similarly, this if exists. So that way accordingly, and that has been already checked some way. So this code you have to write. Now, let's go for the analysis. Time analysis. For max heapify, I can easily see max heapify means either I go from root to this side or this side, even if root is of n nodes, full all n nodes at a time. Say you started from I as 1. I as 1 means you started from root downwards. Either you will go to left side every time or you will go to right side. Finally, you will go to the last node at most. So in worst case, you might go from root to the last node. From node 1 to the last leaf. That will also mean effectively height times the process will be repeated. Height times effectively means it is order of height at most, because in between also it might terminate. So not theta, I can say order of height times, because worst case only it will reach to the last node. Average case or in between, it might terminate before that. So in worst case, it will go to the last leaf from root. All height will be covered. And for a full binary tree, effectively my height is nothing but always order of log n, or I will say to be precise, my height is always log n or log n 1 plus 1, whatever you say. More or less, it means approximately, I can say log n. So I can say my max heap if I can work in log n times. Here it is worth to see, can tree be imbalanced? If imbalanced, then there will be a difference of the height. Like full binary tree only means height to be this. Complete binary tree might have an imbalance. So it is possible, if you mathematically calculate, your left binary tree, left subtree might have 2n by 3 nodes, and right subtree will have n by 3 nodes. You can easily see that if all leaf nodes existed for the left subtree nodes only, right side was totally free, something like, say I have this, and now I have all children up to this only. This side, nothing. So this side nodes are lesser. and this side are going to be 2/3 on one side, except root, and right side are going to be approximately 1/3. Even if this happens, so worst case, I have to go for 3/3n/2 based height. And that height effectively means a log of 3n/2. So effectively that will mean nothing but log 3/2 of n, more or less mathematically something like this. So still that will mean if I solve in terms of doing log calculations, I can say max heapify, if I started from root onwards, from root downwards, the worst case time complexity is order of log n. Now, knowing this, you can easily see that if I have this logic, I can easily see this time complexity is a log n. This I am saying repeat n minus time 1 times. So this time complexity becomes n minus 1 into unit step, and this max heapify n minus 1 log n. And I have to find out the complexity of build max heap. So my time complexity becomes build max heap complexity, this complexity, plus order of n log n. So I have to find out how much is this. If it is more than n log n, then obviously total will be more than n log n. If it is less than equal to n log n, overall complexity will be n log n. And we know, we claimed initially that heap sort is going to be n log n. So I expect this value to be less than equal to order of n log n. In that case, overall, my time complexity will be definitely order of n log n. So now let's go to the final calculations for build max heap complexity. Well, build max heap, if you see the logic, effectively I repeated n/2 times and called max heapify. So it appears that it should be n/2 multiplied by, because max heapify takes log n steps. So I can say it is order of n log n. Yes, appears in the first instance to be correct, but truly speaking, it is not so. Why it is not so? There has to be some logic behind this. I'm going to touch upon some partly this, but for more details, you should read from the book also. Read there for better details, but I'm going to touch upon this, and this is an important point which is discussed in many interviews also. Once you are able to convince the interviewer that you know binaries, heap sort, etc. in a good way, then they might ask you that how build sort complexity will be computed. So ideally speaking, it appears to be n/2 log n because you are expecting this heapify to be log n. But I say this is not log n always. And why? When you started calling this max heapify with I, had I been 1, I equal to 1 means all n nodes exist, because except root everybody is max heapify, so log n is the height. But when I am doing for build max heap, at a time when I called it with I as n/2, at that time, the total number of values in the heap are effectively the, let's say, 4th node and say 8th node only. That's it. So effectively 2 nodes or maximum 3 nodes in heap. One, the root itself, and at most it's 2 children initially. first time. So at that time, saying that heapify will require log of n is incorrect. Similarly, when I will become n by 2 minus 1, then also something similar. Only when you reach to I equal to 1, or then only you have all n nodes, or when I is 2 or 3, you have effectively less than n nodes, and initially you have only 2 nodes, and so and so. So if you say that way, effectively my build heap time cannot be simply said to be based on multiplication of loops. Saying that n by 2 into log n is an incorrect calculation. So not okay. This should be calculated at n by 2 time. How much will be the time taken plus add n by 2 minus 1 node plus add n by 2 minus 2 plus add n by 2 or add corresponding 1. So in this case, height will be initially, effectively you can say 2, or you can even say 1 if you say at most 2. Sometimes it will remain 2. Later it will become 3, and only towards the last it will become log n. Mathematically, if you try to calculate that by doing all mathematical calculations over this particular summation, where I equal to n by 2 to 1, and saying height for node n by 2, for node I'll say, then this will actually come out to be order of n only. So it will be actually nothing but say theta of n, not less than it will be. So build max heap actually takes not n log n. This can be completed in theta of n times. So you should be knowing this. So my total time complexity of heap sort will be, sorry, I'll just correct that. Heap sort complexity will be build max heap complexity theta n plus order of n log n, which we have just seen for loop and max heapify, loop with nesting of max heapify. Here, because max heapify is always having n nodes, rather at lower stages n will reduce, so even that will be less than n log n permanently. That's why we are using n here, although this will also be lesser than n log n, because once n is smaller or n is reduced by -1 towards n, lesser number of nodes will exist into the heap itself. But still I can say this is n log n. So in worst case also, in best case also, this will be perfectly fine. And best case will also, you can easily see, n will be more balanced. Log n will be exactly log base 2n, and factors will be there. So accordingly, still I will be able to do that. So this is the way your heap sort works. Now you should try to implement, and implementation you must do of your own. And once you implement, maybe next class, if you have any doubts, you can ask. So implement heap sort. Now, in this case, there can be many other ways also, like max heapify can be made non-recursive also. So you have made max heapify recursive, but can be non-recursive also. You can think of repeating that process based on without recursion also. Similarly, we wrote heap sort main function as non-recursive, but that can be made to be recursive, that whatever we have done with the size n, same process now to be repeated with this. So this can be made recursive. But while making recursive, you need to know build max heap need not be repeated again and again. So build next heap can be kept out of recursion. That means I can further break heap sort function so that build next heap is kept outside and other part becomes recursive. So that can be recursively called again and again, and build next heap need not be repeated because that will not gain anything by recursion. So do it all at your own level, and it will be a good practice if you listen and read carefully or understand this all lectures today, discussions, and the last lectures. You should be able to write 80% of the code correctly. Always test it for lot of inputs. Always a test for n to be at least 8 or 10 or bigger or odd also. So take all values. Also take all values sorted and unique. You should also take sorted and duplicate. Now duplicacy can be for the smallest value or for the largest value or for any random value also. They can be duplicate. Similarly, reverse sorted and unique. Reverse sorted and duplicate. Random and unique. Random and duplicate. So you must test it for all such cases. And not only that, think of some special or exceptional inputs also. Like n equal to 0 can be probably one situation. You have to think whether my code will crash or not, whether it will create a problem somewhere or not. M equal to 1 effectively should mean nothing should happen. Similarly, negative values, etc., etc. You have to think of those things, whether they create problems or not. So you must test it for all such cases. In fact, all sorting algorithms must be tested in this manner. So you must test for all such sorting algorithms. Thank you. Bye-bye. Wish you a good luck. Try to implement. Doubts will be welcome in the next class. So let me stop now and let me stop.